I really need a way to control every aspect of my LED lighting on my project. Because I'm not a control freak. Really. Dayland with another random making encounter for all of you that are returning, all of you creators, hobbyists, makers, prop builders, RPGers, terrain builders, book nookers, whatever you might be. Good to see you again. If you're new to the channel, buckle up. We're gonna dive into RGB LEDs, specifically LEDs that can be controlled by microcontrollers. These are the big kahunas, the Mac daddies. These are the be all and end all of LED lighting for your projects. So, what am I talking about? First, let me just say really quickly, all of these products that you see, all these things that you see on the bench are, for the most part, from Adafruit. They're a company in New York that's really geared towards makers making cool things. They're cool folks, it's cool stuff, and I'm going to post a link to their Uber guide on NeoPixels. That's what we're calling these RGB LEDs. That's their brand name. I'm going to post a link to their Uber guide. I do encourage you, if you're interested in really doing a deep dive, check that Uber guide out. All of this stuff is generally available on their site. This is not a paid endorsement. I don't even think they do paid endorsements. That's just kind of their philosophy. They don't want to be like pushing stuff through other people. They just want to be as good as they can be on the merits of their own hard work. And they've got some very, very cool stuff. Lots of tutorials, great resource, enough said. All right, when we talk about RGB LEDs in this sense, we are talking about we're really talking about an LED that has a small bit of microcontroller, a small bit of brain tucked into it, which allows us to control individually the red, the green, the blue, and sometimes a white phosphor, an LED, in each individual dot, each individual pixel. We'll call it a pixel. Now, why is that important? Well, it's important because you can sometimes be stuck. You don't want to be stuck with just a red, a green, a blue LED or a white LED that you find in the big box OLEDs, and it's not the right red, it's not the right green. It's always red, it's always green. And how do you control that? It's too bright, it's not the right color. I don't want 6,000 wires. I want to keep it simple, I want to keep it clean, and I want to have ultimate control over the brightness and the color. Well, that's what we're talking about here. This is going to give you total control over your lighting for whatever it is you're building. And we'll talk about some applications in a second. So each of these has a red, green, a blue LED built into them. And then the ones, generally speaking, when you see sort of this yellow or golden patch in them, hopefully you can see that. I'll rotate it around on this ring as well. That yellow phosphor tends to indicate that these are also inclusive of a white LED as well. So in that respect, you can also buy cool white, natural daylight white, warm white. There's sort of the whole gamut of color temperature in those LEDs as well. Now that's important to consider when you're thinking about what you want to buy. If you're just going straight up color, I just need to dial in the sort of the cinematic color of my scene. RGB is going to be good, plenty for you, because you're not going to be actually trying to introduce a natural white light, daylight, or a warm or cool white. It's really difficult with just RGB to just push those all to some equal value and get an actual white light. In theory, it works, but in practice, it's never quite there. So if you want to have the most flexibility in your application, you want to buy some NeoPixels, some pixels, some of these LEDs, and you're not really sure what you're going to do with it, or you're not really sure what the best application will be in your diorama, and you want to actually introduce some white light, then probably an RGBW version is the way to go. They come in a bunch of different form factors. They come in rings, they come in strips, they come in these big grids, they come in little grids. These are both 64 LEDs, very, very different form factor. They come in big grids, little grids, strips, spools, and then they come in individual little sort of buttons. Now, these are actually called buttons. These have solder pads. These have through-hole solder points. If you are not super experienced in soldering, I would say that the through-hole is going to be easier for you to solder to. So that's just a small consideration there. Solder pads, and a lot of these, several of these, many of these have solder pads. They're a little fussy to solder to because you don't actually have anything physically holding your wire in place while you're soldering. So it's a good idea to have some sort of, helping hands or something that you're having hold your board in place. So that's a small consideration. Cost is going to really be a factor of how many LEDs are you buying. So you can buy individual LED NeoPixels in onesie twosie, and they're very, very, very affordable. They're not expensive at all, and it's a great way to sort of see if this is the thing for you. As you start to get up into the bigger rings, and some of these rings get quite large, or you get spools with lots of LEDs on them, or really tightly packed LEDs, they start to add up, as do the grids. They can start to get they can definitely get to be something that's an investment in your project. It's not quite $1 a pixel, but I would say a 64 grid is maybe, I want to say 30, 40 bucks, something in there. That I may be totally off, and you're going to say, dude, you were so far off on that price. Check them out online. I'm kind of just spitballing there a little bit. Little ones, though, for our little tiny projects, totally in the ballpark of most budgets. Okay, we talked a little bit about these, what they come in, what they're cool. Now, the next thing you're going to need is a way to control them. These are basically at the easiest level, we're going to use Arduino. And so you're probably, if you've done any making, you've heard the word Arduino, never maybe know what it means, but it's just a programming sort of platform. It's a tool, and a lot of things plug into or can use the Arduino programming tool that you load on your computer. The best, the most normal is just buying the Arduino brand. This is an Arduino Uno. This is a little on the older side. I've had this for a few years, but the Arduino Uno, so it's this big chunky monkey kind of clunky thing. Old USB, good Lord, you can tell how old this is just by the connection. So Arduino Uno, so you might see big boards like this. For me, what I've been using is something like this. This is an itsy bitsy. This is basically probably more capable than this, and it's a heck of a lot smaller. And these are really pretty inexpensive in the grand scheme of things. So the next sort of step up is you'll start to get to have a little bit more speed in your processor, a little bit more oomph in your processor, maybe a little bit more storage. These are not massive storage things. Arduino programming language is fairly compact, but you might start to find that you need a little bit more horsepower. I start to move up into things like this Metro Mini, still a pretty small form factor. And then if you're really looking for a more complex project, you can start to move up into things like this Feather and start to think about how can you use some additional components. The Feather system has what are called wings that add capabilities. So one really quick idea would be, I need to create a diorama or a book nook or some cool thing that over the course of a day or over the course of a year, the LED lighting changes. So during the day it's one color, then it gradually over the course of the day changes to a different color. During the course of the year, the lighting changes, and you could make this really cool year-long, sort of cool, almost like a clock thing, but in a sculpture with LED lighting. Well, you couldn't do that over here because generally these just don't remember what time of day it is. They have a really hard time with state, like understanding what time it is from power on, power off cycle. So these are really procedural sort of language things. They do this, they do that, they do that, they do that, and then they go back and they do it all over again. And you turn them off, and all they remember is when you turn them back on, we do this, we do this, we do, right? So you need something with a little bit more something. So in this case, this is a real-time clock. It has a battery so that once I've programmed the date and time, it will, regardless of the power state to the main microcontroller, it remembers the time so that when I power it back on, it knows what day of the week it is, it knows what time of day, and so I don't have to worry about losing information through power cycles. So if I wanted to build that clock, I would probably pick up some sort of a real-time clock component, maybe this feather and a feather wing, and I could very easily build that really cool thing. Okay, so you might want to step up a little bit to more capable controllers. Another name you might hear is Raspberry Pi. That's sort of the cool kid on the block. It's been the cool kid on the block for a while now. A Raspberry Pi is really more now, these are microcontrollers. A Raspberry Pi is really more a microcomputer, a small computer. It is much, much more capable, and it's probably for our applications way overkill for what we're doing. Okay, so you'll also need you'll need a couple extra things. You're gonna need a pretty large capacitor. I'll talk about why in a second. And you're gonna need a resistor. The resistor, I'll talk about in a minute. Let's just get to that in a sec. You'll need some ways to hook things up. So you need wire, solder, power supply. If you're powering just a few pixels, batteries are gonna be fine. You don't need a lot of juice to run these. When you start to build bigger, sort of beefier arrays, grids, these can actually start to draw a bunch of power. So in this case, I'm running a 1.5 amp 5 volt wall transformer. And if I were to crank these all up to full brightness, all RGBs firing at 100%, these are actually RGBW, I would actually be overtaxing 1.5 amp wall transformer. So the more you add, the more power you're going to need. So you'd need to step it up into a little bit more robust. Now, I'm never really powering these at 100%, and I'm actually generally never running 64 pixel grids. I just don't have the need in my little projects for that much light. Things to connect. Okay, now let's just talk about basic connection. It's super easy, super simple, and it's really just does not take a lot of thought at all. So this is my grid, little diffuser printed, 3D printed diffuser. You can use other things. These do not get that warm. They do generate some heat. And again, the more pixels, the more heat. So be thoughtful of that when you're using your diffuser material, but this should be just fine. Okay, basic connection for the NeoPixels. You're gonna have your power come in. You need a capacitor, fairly large capacitor on the power. So I've got my ground and I've got my red, my power wire, my voltage in, and then I've got a capacitor properly oriented with to its ground that is bridging those two. It's helping absorb the initial influx of energy into our system. So we don't want to overdrive the pixels by powering on. You could blow some pixels that way. The pixels themselves, the power to the pixels is directly connected to the power with that capacitor in place. Okay, so they're not connected to the microcontroller. They are driven off their own power. They're basically driven off the main power. Okay, I have power to my little itsy bitsy that just goes straight to the itsy bitsy. And then coming off of the itsy bitsy, I have one green, this green wire is my data line from a pin. So the way these microcontrollers work, it's all pin based. So pin 1, pin 2, pin 3. So I pick a pin number, and I connect my data to the data line on my NeoPixel grid. Now, the one thing is we take that little capacitor, and they're recommending a 470 ohm resistor, sorry if I said capacitor early, resistor, and I put that between the data and the microcontroller. And what this does is this helps protect it from the first LED or the LED from spikes coming from the data line, which could damage that first pixel. So this is, again, just a little bit of a security measure. Some of these have that built in, but these I'm just throwing in to just sort of be safer than sorry. Now, why is all of this cool? This is all of the wiring. So what that means is I have 3 wires going into 64 pixels. And that means that through a little bit of programming over here, I can control each individual pixel, its color, its brightness, whether it's on, whether it's off, and I can dynamically change that as we're doing here on the fly through programming language. So, in a nutshell, if you were to think about why this is cool, that's it right now. It is a lot of pixels, kind of as many as the memory can handle in your microcontroller. So each little bit of code, each little programming takes up a little bit of memory, but I'm able to control a truckload of LED lighting at a pixel by pixel basis with one wire, literally one wire and power connection. So if I haven't sold you already, let's actually do this. Let's take this apart and let's plug in a couple other applications. So the first thing I want to look at is, okay, well, let's say I've got some terrain and I want to actually put some lighting in it. I just actually saw a great example of a well that someone posted to Pinterest that was lit, that was sort of this cool mystical well. And it made me just think, you know, good job, loved it. It was a great project. This is just sort of a bigger version of this with more LEDs and really requiring a little bit more space to make it all happen. But if I wanted to put this into my well, I could just build this framework and then slot that right in. So I would just take my little diffuser, push that in. It's a really snug fit because everything, when I baked it, the Sculpey shrunk. Maybe I'm not going to push this in. But, you know, everything's better in theory. All right, never mind. Good try there, Dalen. I would just drop that in, drop a diffuser in, and I could create a really cool shimmering, color-changing effect. If I wanted it to be lava, I could make it lava. If I wanted it to be green, it could be green and shimmering. If I wanted it to be blue, if I wanted it to change, I could do all sorts of things with it. And that's really the beauty of NeoPixels. I can incorporate them into my terrain. So in this next example, I've simply unplugged the 64 pixel grid and I've plugged in this strand of individual buttons that I've soldered together. Now, I'm working on a haunted book nook. I'm going to have a Pepper's Ghost and some other stuff going on here, but I need some basic lighting. But I don't want just any old static lighting. And as I'm building it, I'm not really sure how bright, how dark, how much color, but I do know that I basically need some candle flicker, sort of like a flame effect, like I would get with a little tea candle. And I can do that with these. I also need some ambient lighting, some purples, some greens, you know, some spooky, haunted colors. And I want to be able to dial it up and down based on, once I get it all together, once I get it all assembled, just really fine-tuning my lighting in my book nook. And this is going to do that for me. So if we look at this, it's kind of hard to see, but these first two are running sort of a bit of a random flicker that they have to it. It's changing the color a little bit, it's changing the brightness a little bit, and it has a nice candle effect or a torch effect. I can actually make this more dramatic or less change the color to really dial it in. Then I have a couple that are green and or purple. I can change these. This could be purple, this could be green. It could be different shades of these colors. And I'm going to basically run these through the ceiling, if you will, of my book nook. So there will be a couple that are torch and there will be a couple that are color. And then on the back, in this back area, the same thing. I have 4 different LEDs that I can now individually control what I want the color. Do I want them to be flickering? Do I want them to be a steady color? I can dial up the brightness, dial down the brightness of this sort of ambient mood lighting to really suit the actual final product. So what I'll probably do is tend to increase the brightness intensity in the front area and then to really push that depth back and decrease it. And then I also have a Pepper's Ghost projection thing going on here. So this is really my most flexible way of building in the lighting, but not having to commit to any one thing until the whole thing is put together. Let's look at one more and then let's just wrap this all up. Okay, for this last one, this one is sort of the easiest of them all. I started with an 8-pixel strip and I just pulled out the last example, plugged the same 3 wires in and opened up my Arduino programming on the computer. When you do that, you're going to have to install some libraries. Don't panic, it's all explained in the Uber guide, but in those libraries, there are some examples. And so what I did was I opened up the example RGBW strip test, loaded it onto my little itsy bitsy, and this is what I got. Literally 2 or 3 clicks, and now I have a way to make sure that my wiring's correct and that all of my LEDs are firing. I only needed to change basically 2 values in the program. They're really clearly commented or documented, so it's easy to see what you need to change. The one value was the number of LEDs in the strip, and the second value was what pin, what number pin I had connected my data to. So you can see that these are all changing color, they're all cycling through. And so the example here is, let's say you were wanting to create, your Trolls disco party, you could actually have quite a dramatic light show. The other thing too is if you were trying to build your Cylon Raider and you needed your sweeping red back and forth, it would be very easy to take a strip of these and build a sweeping red and red display. If you're building something for Warhammer 40K and you need something that's much more sort of gritty and mechanical and part of your terrain, your environment, these are great as well. So much more to unpack here. These are such capable little goodies that I just love these things. LEDs, I say this a lot, LEDs kind of make it all better. So when you're thinking about lighting, really give this a hard look because it will add so much more control, so much more richness to your projects and really open the world to you. And the technology, the programming, the language, don't be intimidated by it. Like I said, if I can do it, you can do it. And there's so much documentation. There's so many tutorials and so much help out there. Post a comment. If you have questions, let me know. Throw them down in the comments section. But I hope this was at least really, inspiring, piqued your interest in these. I definitely encourage you to check them out if you have any interest at all in lighting. And thank you for watching. Hit that like button, subscribe, follow me on Instagram, all those good things. But we'll see you back with another random making encounter really soon.